Absolutely. Let us begin. So hello, everyone. I'm Judy, and I'd like us all to introduce ourselves. So Guy, may I hand over to you? And also, please share with everybody your Japanese name.
Okay, yeah, Matsume is my Japanese name for Pignole. It is just a straight into Japanese because I've been working with Japan and in a close connection with people who have been sailing from the Earth to Venus 10 years ago with the Icarus satellite. And we have a project which is called Payanque to have a solar cell which will be 7 meter by 7 meters, that's 50 square meters, with a central cube, which will be based on various parts of electronic equipment, including much of the equipment which Judy is taking care of.
Absolutely.
So that's it.
And where are you from?
So from Reunion Island, and the Reunion Island I have here, it's an island in the Indian Ocean, 1 million people. It's part of France and Europe. It's part also of China. It's part of India. We've come from all over the world, all kinds of people. And the project for the Earth-Moon Challenge with solar sailing is going to be a world project cooperation assembled in Reunion Island. And in a former life, I was chairman of the education committee of the World Federation of Astronauts.
Great. Guy, thank you. Thank you very much. Wonderful. Laura, would you like to introduce yourself?
Well, the thing is that my name is not Loira. I don't know why that name appears. My name is Ana Vidal, and I am an assistant professor in University Politécnica de Valencia. And we are just starting with your chips, and we wanted to have your explanation in order to work with them, with our students. So I'm ready.
Fantastic, and absolutely wonderful to meet you. Maria, it's wonderful to see you. And so, yeah, welcome. And please introduce yourself.
Yes, nice to meet you finally.
Yes.
My name is Maria. I am a colleague of Ana Vidal. I am a researcher at the Technical University of Valencia, Spain. And we were interested in these kits because we are giving a course to high school students to promote their STEM skills. And these 6 chips are perfect because you don't need any knowledge of electronics or programming to start. So we are here for learn more about this.
Fantastic, Maria, absolutely. And what we're doing is we are building a community of people who have the kits and who can help each other and collaborate around the world. Absolutely. So great. Wonderful to see you. Emmanuel, hi. Hello. You're joining us from Italy.
Hi. Yes, nice to meet you. I'm Emanuele Gardillo. I'm an assistant professor at University of Messina in Italy with Professor Cademi. And I work in the microwave electronics field. And I'm very interested in this event because we are starting to develop CubeSat. And I'm ready to start. I'm ready to learn.
Wonderful. Excellent. And hello, Paul. How are you doing today?
Doing good, doing good. Yeah, so background, I used to work in space as like a space systems engineer. And I took like a 6-year break from the industry, but I'm now getting back into it and just using CubeSats as a way to kind of get some hands-on experience working on some technology. And I bought these kits. It's kind of like an intro to that world, but I'll get, you know, more intense with it as I get more skills. And side note, I was in Valencia about a month ago and I loved it. So I envy you guys and your weather.
Great. And Paul, where are you now?
I'm in Seattle, Washington at the moment.
Great. Fantastic. And Francis, hi. Thank you for joining us. Would you like to introduce yourself? Hi. Hello. Francis, can you hear us okay? We can't hear you. I'm so sorry. Francis, we can't hear you. Let me, something happened there.
Yeah, it looks a bit laggy.
Yeah, I think it could be the connection. I'm gonna quickly pop him a message to let him know that we can't hear him. Chat, here we go. Francis, can't hear you.
Hello.
Oh, okay. He's saying he can't. We can't hear him, but he can hear us. So, okay, Francis, I'm sure that. Yeah. Well, I mean, you can type very quickly. So that looks okay, and I hope that you get it working while we're there. So what I'd like to do is, because we have a number of people who are joining us for the first time, so those of you who I have met before, please give me a little bit of leeway here. I want to share with everybody a little bit about the XinaBox chips and where they come from and where we're going to and all of that kind of thing. So what happened was that I'm in Cape Town in South Africa. I'm a South African. So that's the accent you can hear is a South African accent. And in 2014, we realized that we needed to roll out a STEM program in our high schools across South Africa. And my husband and I have been running a non-profit organization doing outreach into communities for a number of years. I myself, originally, I'm a chemical engineer, and my husband, Biaka, he's an IT engineer, a developer. He's a geek, he's a coder. And so the thing is that what we thought was, in order to create the inspiration and the enthusiasm for the program, what we would do is we would have a look at space. We would roll out a space STEM program. We were able to secure our first major sponsor, which was actually a Japanese company, Isuzu Motors. They have a number of factories in South Africa. So they were our first sponsor, and they said they were very, very happy to sponsor us, but we didn't know what we were talking about. So the first thing that they paid for was for us to go to a number of workshops and a number of conferences to actually learn how we were going to do this and learn a little bit about space. And it was on our very, very first workshop, which was the CubeSat Developers Workshop, at Cal Poly in California. We met Professor Bob Twiggs. And Professor Twiggs, at the time, he was working at Morehead State University, and he invited us around because we were there in the USA, and we went to visit Morehead State University, and we saw the program they were rolling out in communities to attract youngsters to the university. And what they were doing is that they were having these students design CubeSats, and then eventually a number of years later, they were able to arrange flights for them with NASA on the NASA flight program. So we felt that this was really a perfect match. And with all of the blessings and all of the permissions, we returned to South Africa and began implementing our program in South Africa. Now, our challenge was that it was too expensive. It was way too expensive for the impact we needed to have. Then there were other factors as well. The first was it was too expensive. The second thing was it was too analog. It wasn't digital enough. So we were spending way too much time on soldering and breadboarding, and we weren't getting to coding. And we had to get to coding a lot faster. So that was the second challenge, is it wasn't digital. When it comes to the cost component, what we needed to do is we needed to have components that were robust enough and low cost enough that we could leave the kits at the schools. Because the thing is that what we found was with a number of outreach programs, they would go to a school and then they would take the equipment away again at the end of the day because it was too expensive to leave there. And we didn't want to do that. We wanted to leave it at the school with the students. Yeah, and the thing is, what we needed to do is we needed to make sure that we were using exactly the same technology in the classroom that we were going to be flying in space. We needed that connection to be there. So what happened was that we couldn't find anything. So Bjarke decided that he was going to develop something himself. So that is when he developed these XinaBox chips. Now, the thing is that Bjarke is Danish and Lego is Danish. So that is why it was very easy for him to have these standard sizes, you know, and a standard connector and one communication protocol and one voltage, etc. So what he did is he started off by designing his standard and his design methodology before he actually designed the first chip. So he thought about everything and he made sure that everything could run I²C and that everything was digital. And if it wasn't digital, if it was analog, it was converted to digital on the board so that the students didn't have to worry about converting from analog to digital or anything. So what we did is we built our first prototypes in 2015. And we started rolling out in 2016, and it was really going very well in South Africa. We showed it to Professor Twiggs in 2016, and he said, this is what we are going to use. So that was, then we realized, wow, we actually have to build this as a business. This is no longer a project. So this is now, it has to be a real business. So we employed engineers and we employed people who knew about manufacturing and all sorts of things. So we could actually put it together and build it as a product. So we still run a lot of outreach programs on the African continent, and we engage with a lot of nonprofits around the world to run outreach programs. And thanks to Professor Twiggs, we were able to launch over 80 satellites into orbit on the ThinSat program. So what we did is we used exactly the same chips. So if you have a look at this, this is the SL, this is an SW10. So that's a surface temperature sensor. Here's the light sensor. And you will see that it is exactly the same light sensor that we have here on the kit. And they use exactly the same connectors and everything. So what the students did is that they built their ThinSats using these chips in the classroom, and then they were sent to Moorhead University, integrated into the P-pod, and then went to Northam Grumman for launch. So the thing is that the reason why we did these ones in black is because we had to put these through thermocycling. We had to have a much broader tolerances for these chips. So they were slightly more expensive to make. So we had a limited range of these that were actually going to go into orbit. So when we produced these, we produced them at thousands, tens of thousands at a time. These we produced 200 or something of each. So we have succeeded in being able to put the tech into orbit. And then every year with Space Tango and the Quest Institute, we have a kit on the International Space Station. So it goes there either with the Cygnus module or with SpaceX, and then it always comes back with SpaceX. And so here I have the kit that was there this year. So it's come back. And so this one actually has a wire. Can you believe it? We try to be wire free. And then you'll see here, all the data was collected on an SD card on exactly the same component that you have in your kit, that's CS11. So this is a particle matter sensor. This is a really large, very heavy sensor. So we don't put this on the high altitude balloons or anything. So this kit collected data on the International Space Station for 5 weeks. Air quality of the air on the International Space Station. So that was quite fun. So every year we have a slightly different project, and then students around the world, they have a matching kit, so they can collect data in their own environment, and then we compare the data sets. So yeah, so we've got a little bit of space heritage, and then next year we're starting with our rockets challenge, and next year these same kits that you all have, we're going to be flying those on a suborbital mission with Blue Shift Aerospace. So what Blue Shift Aerospace are doing is that they've developed a rocket that uses a biofuel engine, and they're doing a series of tests. So what we've come to an arrangement with them that we can fly student payloads on their rocket. And so, yeah, so everyone who has these kits, you'll be able to actually put together your payload, and we'll get it to Blue Shift. And then around about August next year, it's going to go on a suborbital launch. We're looking at around 350 kilometers in altitude, but you know, it's suborbital, so it's recoverable. And so we should recover our payloads. So yeah, that's a little bit of background about us. And this particular kit that you have, this CubeSat kit, we developed the kit actually originally for the schools in the USA. In 2019, the Federal Department of Education wanted to run a CubeSat challenge amongst high schools in the USA. And they needed a kit that was going to be less than $1,000 in cost for schools and students. And so we felt what we could do is we could put together a kit, and we could do that. So we put that together, and I must say we've learned a lot along the way, and we keep going from strength to strength to strength. So yeah, that's a little bit of background. And so before we get into the detailed questions, do we have any questions to start off with? Paul.
So if anyone wants to launch on, once they have their CubeSat mate, anyone has the opportunity to launch on their payload?
Yes.
And then
yes.
How do they coordinate, like sending, I guess, their CubeSat to the location or to you, or how does that work?
Yeah, that what we've done is we've set it up that what we're going to do is that, for example, when you book your payload space, so what it's going to be is it'll be a slice of a CubeSat. So what we've done is we've built a 3U container that, you know, on one hand can accommodate the XinaBox payloads, and then also what it is that it integrates with the Blue Shift Aerospace payload bay. So what they want is that they want 3U volumes. So we've done that, and that is all being coordinated by my colleague William Edmondson. He's based in Virginia. in the USA. So what's going to happen is that William and his team are going to receive all of the kits from around the world. It's all going to be integrated, and then it's going to be shipped to Blue Shift Aerospace in Maine on the East Coast. And then once it comes back, then they get redistributed to everybody around the world. So we've set up the logistics that the kit goes to the launch and then comes back to you afterwards. We do know that a lot of people aren't going to be able to attend the launch, but when we get closer to the time and when we have some firm dates, then certainly, people will be able to attend the launch if they want to attend the launch. Paul, I'm sure, coming from the aerospace industry, in the US, usually what happens is if there's a launch, it'll be, let's say, for example, a payload to the International Space Station, and then there's like a lot of security around it. It's very expensive. It's very difficult to actually be able to attend unless, you stand on the side of the road, a few kilometers away. But with Blue Shift being a startup company, and they're like small and gritty and agile and fast moving and everything else, everyone's going to be able to attend. It's not a security related payload that's been launched, so anybody can attend. So we're expecting it to be quite festive on the day.
Nice, love it.
Yeah, it's going to be good. I've had a number of discussions with Virgin Orbit about launching with them. And, the thing is that they've got very much commercial prices. So it's, right now, it's not very affordable, with Virgin Orbit, which is unfortunate. But let's see how those discussions go, because what we're doing is we're having a look at whether we can get some assistance from the Virgin Foundation called Virgin Unite. And then, if that can then subsidize the launch cost, then we can start looking at some orbital launches with them, which could be really good. Blue Shift Aerospace they're doing their first orbital launch probably in 2024, so we don't have to wait too long for them.
Rocket Lab and Astra may be good companies as well.
Yeah, absolutely. So we've reached out to everybody to get in some quotes. So yeah. I think that one of the challenges is that the student payloads are always going to be very much secondary or maybe even tertiary payload. So, with Rocket Lab, they're always looking for their primary payload. And then, once they've secured that, then they start offering up 1 to 2 U spaces, to go with it. But yeah, absolutely. Good. Any other questions?
Since we are located in Italy, we were thinking to explore some opportunities, talking about launching, to take advantage of some educational program given by the European Space Agency.
Yes.
So we will explore that opportunity.
Absolutely. You definitely would be able to do that. And I do know that the Italian Space Agency is very strong and very well connected with the European Space Agency. So definitely, I think you'd be able to do that. Absolutely. They have a very strong outreach program. So that could be something really great. Airbus supports a lot of programs. So you may be able to have a look at that in terms of getting some funding from Airbus.
Okay, thank you.
Yeah, absolutely. So
one, please.
Yeah, Guy, yes.
I'd like to say that in Germany, there are private startup rocket companies, very much like Blue Shift, which are supported by it's ESA and RFA.
Very good point. Yes, you're very right. There's apparently there's over 90 rocket startups at the moment.
Even in
across the world.
China, you have some startup companies.
Yeah, absolutely. Definitely. So the fundamentals of the kit, what we really want to do is that we want to, certainly when it comes to anything to do with satellites, there's some fundamentals that we want to cover. And that is why you have your ground station and you have your flight station. What we've done is we've used these flight stations a lot on high altitude balloon launches. And because they have the GPS module on them, we have actually recovered quite a lot of them. So these are used a lot on high altitude balloon launches using helium or hydrogen balloons. Using the long range radios, these LoRa radios, we find that we can get a really good communication and we can get quite a long distance link. So those are quite effective. There's a very strong movement at the moment to use LoRa radios for satellites, and there are a number of CubeSats that are in orbit at the moment using LoRa radios and ground stations. So we're pretty pleased that we chose that technology, and we're going to continue moving in that direction in terms of building a ground station network, etc., to be able to support those satellites once they're in orbit. Yes, Guy.
Yes, so this is a ground station for a balloon that will go a few kilometers, a few tenths of kilometer, and this antennas are okay.
Yes.
And if we're gonna have satellites, and in hundreds of thousands of kilometers, we need large dish antenna.
Oh, yes.
Are you thinking of connecting this ground station to a large dish antenna? So if we have a large 15-meter dish antenna on the ground, we can use this on the moon.
Absolutely, Guy, we certainly are. Let me see if I've got it here. Yeah, because it doesn't always need to have the SMA connector. You know, here I've got another one. This has got a different connector, so I can put a flexible antenna on it, etc. So the module itself, the LoRa module is the same. But yeah, the antenna connection can be different. We can connect it to a dish, whatever it needs to be. So yes, you're absolutely right.
Yes, we may have a different approach for
yeah.
connectors for
Yes.
what is educational school kits.
Yes,
and
yes.
Space equipment. I'm not sure the famous X will hold very well with the vibration you have during the launch and things like this. And maybe we need. But this is
but we test
quite
for that.
feasible.
We'll design for that. So yeah, absolutely.
Needs design, but it's not.
And testing.
Very difficult.
Yeah, absolutely. So so the thing is that there's a number of fundamentals that we want to be able to get across, and especially for the high school students and for undergraduate students, for them to be able to work with a number of the different concepts in terms of satellites. So the one is radio communication, having a ground station and a flight station. And the thing is that what it is that we have it's duplex. So we have communication from the ground station to the flight station, as well as from the flight station to the ground station, which is really important. Because not only do we want data to be able to be received, but also if we need to send a kill signal for some reason, or a radio silence signal, we need to be able to do that. So we need to have the two-way communication. So we have that. The other, another element we need to look at is payload. In terms of payload, we have a number of different sensors. So we've, in this kit, we've given you sensors that you're not going to fly in space in orbit necessarily. Like, for example, this SG33 is a carbon dioxide and volatile organic compound sensor. So, I mean, it was very useful inside the International Space Station, but it's not useful on a satellite itself. And then, but you know, the thing is that you have your IMU, your SI, you may have an SI01 or an SI02. And this is going to give you pitch, yaw, roll, acceleration, G-force, etc. And what I do is I always put it in the middle of my kits so that it doesn't, so that it has the least interference as possible. Your light sensor, as I mentioned earlier, your light sensor is going to give you light intensity and ultraviolet.
By the way,
yes,
I have here two different S01.
Yes.
And one works with the meteo station, the other one does not work. And
Yes.
they don't look the same, but
Yes.
they have the same denomination.
Yes. Guy, I'm actually thinking the one that doesn't work, I'm going to find a way that you could actually send it back to us so that we could understand why that one doesn't work. We have
it's built differently. It's a very different build.
Oh, okay. Yes, originally we had these where we had two different sensors for light and UV. And then one of the sensors went out of production. So we changed it. Yeah, so now it looks like this. So it looks slightly different. Yeah, it looks slightly different. If we have a look at those two light sensors, you can see this one's got one component on it and the other one's got two components. The code should be updated to accommodate both. And that is why, Guy, I was just wondering, maybe we need to get yours back to try to understand why it's not working with your code. So that is the light sensor.
I'll send you pictures.
Okay, great. Thank you. And then, but is it working with your XK90 code, or is it only not working with your starter kit code?
I have not yet operated the X90 code.
Okay.
The equipment.
Okay.
I just operated
with the starter kit. Yeah, with the starter kit.
The starter kit. Because
okay.
I'm very busy on the project, and in the next few months I'll get into that.
Yes, that's absolutely, and that may be the reason why. But I think if you tried with your XK90 code, that code has been written to accommodate both sensor versions. Okay. So it should work. And if it doesn't, you need to let me know. Absolutely. And then we have a weather sensor. So you've either got the SW01 or the SW03, and that is going to give us temperature and atmospheric pressure, which are really, really great in terms of when we have altitude on a high altitude balloon flight, then you really start seeing atmospheric pressure being affected as well as the temperature. So that is in terms of our sensors that we have. So with the flight station, the input is the sensors and the output is the radio as well as to the SD card. So what it'll do is it'll save the data on the SD card as well as transmit it via the radio. So that's the output. It has two outputs, the radio and the SD card. And then on the ground station, the input is the antenna, and the output is your little OLED screen, perhaps, but really, really importantly, your output is actually this Wi-Fi hub that you have over here, the CW01 Wi-Fi hub, and that goes to the dashboard. So what I'm going to do is now that we're on output, let me show you what the dashboard looks like. So this is an example of Oliver in Georgia. This is Oliver's dashboard. So what we've done is we've developed a template dashboard for you so that you can just start using it before you want to do any of your own visualizations. And on the help page, I'm going to give you the link to the help page. On the help page, it'll take you to the dashboard. It'll give you the password, the username, etc. But just so that you can see here, this is coming from our GPS. Our SN01, Sensor Navigation 01. And so the thing is that it'll show the whole globe. And then what we can do is we zoom in here to have a look at Oliver's kit. So this was data that was collected in April this year. And so there we go. We can see over here, during the time, I don't think the kit actually moved anywhere. By the way, are you all seeing my browser? I'm assuming you can see my browser. Yes, can you see can you see that? Okay, so if we okay, we can see that it wasn't actually moving. I'll show you another example of the dashboard where it was used on a high altitude balloon, and there you can see the movement as it was tracking the flight. Okay. We have battery voltage, so we can see over the period that the batteries were being used and running out. This volatile organic compounds, very low, so it wasn't registering. And then so when there's nothing in the dashlet, it means that it doesn't mean that there was no data collected. If there was no data collected coming from the sensor, it would give like a frowny face error message. So that is why I know that the levels were just very low. Because the gas sensor, the SG33 is only going to measure from 200 ppm and higher. It's not sensitive enough to measure the really low concentrations. And then here we go. Here we can see what was happening with temperature. Pretty warm day, 21 degrees centigrade in Georgia that day. Atmospheric pressure varying over time, relative humidity varying a fair amount. And then here is the data table. So what one can do is one can actually download the data either raw or formatted. So this is all the data that was transmitted by the flight station to the ground station, and then using the Wi-Fi posted to the dashboard. Okay. Yes, Guy.
What I've seen so far from the dashboard is that it's a community software. I have not found a way to have it only for local use, autonomous, independent of any of the connection.
Sorry, just repeat that quickly.
Can we have autonomous operation of the dashboard? Or is it only a community system which includes where you have all the dashboards of different users put together?
Guy, you certainly could have. So what it is that the data, what we do is that the data using Wi-Fi posts to an MQTT server. So the thing is that what you could do is you could set up your own MQTT server and your own dashboard. And then what would happen is then we would just need to change the code so that it posted it to your MQTT server. And we have done that in some cases where we've run programs for school groups with the ThinSat program for Virginia Space. They had their own MQTT server and their own dashboard and everything. And we actually had no sight of that data at all. That was their data. So, yeah, what we're doing is we're running this Kibana dashboard very much as open for everybody so that they can get going. Yeah, but you certainly could do. You certainly could have your own. Absolutely.
That we are keen to develop that kind of system in Reunion Island. And Willie Lameyer, who is not with us today, but is very close and very active in the school system. And we would be happy to have, you know, a Reunionese local system of dashboard without going to Minnesota, Arizona, and so far.
Yes, you could definitely do that. When you're ready, I'll make sure that you have a call with Bianca, because then he will help you through how to set all of that up. Yeah,
because on the screen, I didn't find any way to access anything that would allow me to cut from the US system and have our own local.
Yes, absolutely, absolutely. So what we do is we run this.
And I don't know how you feel in Spain and in Italy about that.
Yeah. So we currently run this on Google. We run it on Google. We tried to set up one with Amazon Web Services, but it wasn't as stable as what we have right now. So yeah, you can set it up as you wish. Absolutely, Guy. Absolutely.
And for some specific uses and operation, of course, it's very great and useful to have global systems, but not always.
Absolutely. Do we have any other questions right now?
I have a question because, as you mentioned rightly, most of the sensors are for balloon operation at the time, and some have been for the atmosphere, like the ISS and so. We probably would need much of image and cameras.
Yes.
And of course, because of LoRa, it may be difficult to have movies, but still picture we would need a lot. And I'm sure that still picture can go very well with LoRa.
Absolutely. So what we have is we have a Raspberry Pi interface. And the thing is, what we have done is in some of the projects, it's flown with the Raspberry Pi as the core. And then there's a lot of cameras that one can get to connect to the Raspberry Pi. So we certainly have done that. Bianca's working on a camera unit. It's in prototype at the moment. But yeah, we don't actually have our own camera unit right now. We do have,
I would like that.
two infrared, we do have two infrared imaging chips. So that those are quite interesting. Yeah. So yeah, we're working on the camera. We don't have our own camera chip right now. Yeah. Guy, you're absolutely right. You know, the thing is, a lot of it, what would happen is we are looking for suggestions from everybody in terms of what sensors you would like to see on your satellite. Because we don't come from the profession ourselves, we come from other professions. We we struggle with what sensors would be really useful. So we are looking for all kinds of suggestions. What we have done with 3 schools, what we've done is we've shared with them the design methodology and the footprint for the chips. And then what they've done is that they've actually put their own sensors on the board. They've designed their own boards because our design is free and open. It's not proprietary. Yeah.
It may be fancy at this time, but I think not for long. Be happy for space equipment to have star sensors.
Sorry, Guy, have a
star sensor.
A star sensor.
Yep.
Yeah. No, I mean that's a great suggestion. You know, so that's the kind of suggestion.
Because you mentioned the initial for motion detection. But infrared. If we have absolute reference, once you are out of the atmosphere, there are 2 things. First, the brightness of a star is something that can be useful just to recognize the main star just by the brightness. And the spacing, and you can have also maybe miniaturized thing. Will allow you to have the attitude of your carb, your sensor, in the local star reference system.
Yes, but definitely, because what one could do is one could actually do quite a lot of computing on board, and as you say, almost image recognition. So from an orientation perspective, one would be able to do that. That could be very interesting.
Well, another interesting thing is that we may have actuators and especially ion drives.
Yes.
You know, there are increasingly people who develop ion drives for CubeSat.
Yes.
So could we have an interface to control ion drives?
I'm sure we could.
Okay, that's an idea.
I'm sure we could. About. Yeah, because we would simply interface with that core. You know, that the
when
CPU
you
that's
mean
running
maybe through the XBRP and things like this, but okay, we need to have a total CubeSat control system.
Great. So one of the other aspects that we really want to share with the students is the whole aspect of power management and temperature management. So yeah, what we have is it's a really simple battery unit, AA battery unit. But the thing is, it will give you data in terms of current and voltage. So you'll be able to measure your battery health at the time. And it's really interesting to see how battery efficiency and current flow is affected by temperature. So there's a number of experiments that the students do where they put it in a freezer, they take it out, they put it in a warmer environment, and actually see how that affects the operation, because that is something that really needs to be designed in when designing the satellites. Is what are we going to do about thermal management? What are we going to do about power management?
Yes, we also need interfacing with solar panels.
Yes, we do.
And storage, maybe like high performance capacitors rather than batteries or things like that.
Absolutely. So we do. We have LiPo battery modules, and then we certainly do have one that will work with the solar panel. Absolutely. That's it. I'm not sure if everybody knows, but we have over 80 different X chips, so which you can add on to your kit. So your kit
Yes,
is
can you please send me a list and data about your 80 X chips?
Yeah, I think I've sent it through, but I can distribute that to everyone, definitely.
Okay.
That list. So yeah, and then in terms of power, the biggest challenge you're going to have with this kit, surprisingly, is going to be the Wi-Fi. And that is not because of the X chips. It's just the nature of Internet of Things. So what we've done is we've chosen this particular module. By the way, if you want to see what modules they are, what I'm going to do is let me actually open another tab, and then I can also share it with you. I'm going to go to the XinaBox website, XinaBox.cc. Okay, and then what I'm going to do, let me actually share my screen. Where am I? Okay, so there we go. So let's have a look here. The XinaBox website. And then what I'll do is I'm going to look for the CW01. So our naming convention, if it's a core module, in other words, if it has a CPU on it, it starts with a C. CW01, core Wi-Fi 01. The other core you have is the CS11, which is the core SD card 11. Okay, so let's have a look here at what do I want? I want my CW01. Let's just search for that. Let's go here. So Guy, this is the kit that you purchased, that starter kit. Okay, so if when I go to the CW01 Wi-Fi, you'll see here it says in brackets, it says ESP 8266 ESP12F. So what you can do is when you Google that, you will be able to get hold of all the libraries for that if you don't want to use our standard libraries. Okay, so the thing is that we selected this particular board and this core because it's extremely popular, and so therefore we knew that we were going to have a lot of libraries for it. The challenge is it's very power hungry. So, and that is why we use the USB connection for it, because if we were to connect a battery unit to it, it would drain the battery in minutes. That is actually how power consuming it is. This core that we have here, this CS11 is very, very low consuming. So these batteries on this flight station will last many, many, many hours. Whereas on the ground station, definitely not. So if you have a challenge connecting to the Wi-Fi, it's probably because you haven't got enough power to it. So what I do is I always connect it. Sorry, we're moving house at the moment, so everything is in complete disarray. So here we go. So what I usually do is I usually use a USB and I actually connect it to the wall. So that I can put power into it directly. Even if I have a power bank, sometimes it's not good enough. So yeah, if you have any challenges with the Wi-Fi, it could be because of power. Another thing is it's got a very, very small antenna. So you need to have a strong Wi-Fi connection where you are. So what I do is that I have my own Wi-Fi hub in my office. so that I can ensure a strong connection. Because I found that if it was in another room, sometimes the connection was too weak, and then it would look as if it was connected, but the data wasn't being transferred. So that's another thing. So you need a lot of power in terms of electricity. You need power, you need a strong signal. And then, yeah, what also another thing is that it won't handle enterprise Wi-Fi security. So it'll handle standard Wi-Fi connection where you've got a username and a password. But if you've got a 3-level sign-on, it's not going to work with that, unfortunately. So what we find is when we are in a school environment or a university environment where they have an enterprise Wi-Fi, what I usually do is I just have my own router with a SIM, and I just use that to connect my kit. So the thing is that the data that's flowing is bits and bytes. As Guy said, it's not video or anything like that. So you don't use much data at all. A few dollars worth of data feels like it lasts forever. So that's also just another thing that you need to take note of. And it's not unique. Yeah, it's not unique to XinaBox, but it's one of these things when we're dealing with Internet of Things and we're connecting a lot of devices to Wi-Fi, sometimes we have these challenges. So the interesting thing is the biggest challenge you're going to have with a satellite kit is actually the Wi-Fi on the ground station. But you will see in the help page, I'm going to give you the link again. In the help page, there's a lot of troubleshooting in terms of overcoming those challenges. When you go through the process and once you've built your kit, what you'll do is you'll use one set of code for your ground station core, or one set of Arduino code, and the instructions are quite clear how to get hold of that. And then there's another set of code for the flight station. That code is going to go onto your SD card. So you'll need an SD card, but it can't be too large. It can't be larger than 16 gig. It needs to be smaller. So I usually go for 8 or 4 a gig in terms of the SD card. And that's also Arduino code. So what we've done is we've pre-developed the code so that everyone can get up and running relatively quickly. If you want to develop your own code, just send us your GitHub profile, and then we will open up our source code and everything to you, and then you can work in it. So in this particular case, we've developed it in Arduino, which is Italian originally, and but you can code these chips in Java and Python, C and C++. Yeah, so what will happen is we've got this SN01 here. Sensor navigation 01 is your GPS. This GPS, it needs to download the almanac. So what it needs to do, it needs to download that almanac so that it can actually position itself in terms of the GPS satellites. What you can do is you can keep it running for maybe a few hours, and it'll download the almanac itself using its own little chip. Otherwise, what happens is we've set it up so that when you connect your ground station and your flight station, the ground station downloads the almanac to the flight station. So when you start your kit up, you'll see it'll say something about almanac, and just let it run for 5 or 10 minutes. And then what it's doing is it's loading the almanac to the flight station. So yeah, when you get your ground station up and running, you'll see on the screen, it'll scroll through the steps that it's going through in terms of configuring the flight station and all of that kind of thing. Are there any more questions for now? I think the main thing is to start, because you are going to find some challenges along the way. Emmanuel.
Is the almanac download required every time you switch on the board?
It depends on how long you've had it turned off. It's a little bit like, remember the original days of GPS in 2005, 2006. You know, if you had it turned off for too long, it took quite a while to upload the almanac. It's a similar process. What I find is that I turn my kits on and off every few days. So I find that it's not an issue. Okay. It's not an issue. And the thing is that the idea is that you need to take your time in going through each of the steps so that you allow it time to actually, especially the first time, to download that almanac. But you shouldn't have to do it from scratch every time. Yeah.
Okay, thank you.
How far is the distance that ground station can communicate with the flight station?
It depends very much on line of sight. But the thing is that what we found is that there's you'll see that there is a link to understanding the LoRa radio and the link budget, etc. But we're certainly looking at 100 kilometers or more. You know, but it depends very much on if you have line of sight. So if you have a high altitude balloon launch, that's fine because you've got some altitude. And that is also why it can be okay for using on student satellites. Yeah.
100 upside or also?
Yeah, as long as you have line of sight. Yeah. In terms of your, also the thing is, what will happen is that the radio waves bounce off the ionosphere. And that was something that Marconi really got right, is he realized we didn't have to see the antenna to communicate with it. So yeah, that's there's a lot of learning for the students in terms of understanding radio technology, because we've got a number of radios. We've got the pair of LoRa radios. The Wi-Fi unit is a radio. And the GPS are using radio technology as well. So the students can learn quite a lot about various forms of radio. Yeah. I'm going to, let me put the link into the chat again. So let me just go there. So what I'm doing is I'm sending you the link for MaxIQ, because that is the business that is very, very, very actively running in terms of supporting XinaBox. XinaBox is nowadays is purely a manufacturing business, which is okay. You know, focus is required sometimes. One can't try to be everything to everyone. So here we go, getting started. So the XK07 kit is the one that we use on the high altitude balloons, and the insides, the X chips are completely identical to the XK90 kit. The XK90 kit has those CubeSat interfaces and the backing boards. So what I'm going to do is I'm going to send this through. I'm going to put this in the chat. Let me just clean it up a little bit. Here we go. Here we go. Do we have any more questions? So what I'm very happy to do is I'm very happy to have another workshop probably 2 weeks from now. So that you have a chance to get everything up and running, and then you're going to start coming with your questions. So Guy, please, I need you to start building your kits.
Okay.
Okay, please. And what I'll do is this link I'll send to all of you in the email as well. Yes, Maria.
One question, Judy.
In December, I'll have time.
Good.
One question related to the program. When we try to program the ground station, sometimes we have problems with the provisioning window. Sometimes doesn't appear, and we have problems with that. Maybe with the same computer, sometimes it's resolved to change in the computer, but if the provisioning window doesn't appear, all fails because we have any way to pass the Wi-Fi code, the pass on.
Absolutely. Yes, because you need to put in the Wi-Fi credentials there. Yes, Maria. So that is a challenge you're having with XinaBox Uploader.
Yes.
The application, absolutely. So, yeah, we have got an XinaBox Uploader troubleshooting site. Let me send that through to you as well. I know it's been very difficult. We've developed it for Windows and for Mac. But the thing is, we find that on some computers it doesn't run very well. Especially with computers that have been locked down security-wise, maybe by a university or by a corporate environment or something like that. I find what really helps is that if I download Arduino and the Arduino drivers, etc., then it works very well because it uses those drivers. My challenge right now is I've got a beautiful, beautiful new MacBook with an M1 chip, and it doesn't work on the M1 chip yet. So I have to use my old laptop for XinaBox Uploader. But what I'm going to do is let me find that troubleshooting page for you as well, because yes, I know it's so strange. And what I find, especially with Windows machines, what I do is I delete the app and I re-download the app. And for some reason, then it works perfectly again. And I don't know what it is.
I don't know why. Sometimes it's the same computer, maybe
I know
the computer.
I know. I'm so pleased it's not an app that we try to sell. But the team's working on a completely different app and completely different methodology. But obviously we'll only bring that out later. Wait, did that page actually work for you? I'm getting an error page here on that link.
Yes, Judy, the link seems not working.
Okay, yeah, but I deleted too much of the search bar. Okay, let me correct that. There we go. I had deleted the word kits. That should work. Please test that. And then I'm going to also look here for XinaBox Uploader.
Yes, now it works.
Now it works. Great. Thanks so much. Okay. Using XinaBox Uploader. Here we go. Okay, that one as well. And yeah, you see, and that's also relating to the ground station, because you're going to use XinaBox Uploader for the ground station. So yeah, you're gonna celebrate when you get your ground station up and running. That's the most difficult part. Wonderful. Are there any other questions? Francis, you're very quiet.
I wonder if my microphone's working now.
Yeah, we can hear you now. We can hear you
Oh,
now.
fantastic. I think if I have the video running and my audio, it messes with my bandwidth or something like that.
Could be, yeah.
Essentially, I was gonna have questions, and while you guys were having your discussion, I decided to just fiddle with my ground station, and I actually got it to connect to my flight station, even though I've been trying for like 3 weeks. So maybe it was just the luck and you guys' energy that helped me. But you know, here we are, and it's reading properly. So yeah, it's perfect.
Okay, that's great. That's perfect. Good. I have to say, sometimes I power them up and then I walk away, go and have lunch or something, and then come back. Because if I try to fiddle with it too much, I think, I don't know, agitate it or something like that. So yeah, good. And are you able to see it on? Are you able to see your kit on the dashboard?
That's exactly what I'm setting up right now. My team actually has 2 of these kits, and so we have one kit that is functional.
Great.
And we can read that one. So this one is just like essentially like a backup that I just want to set up in the event of like practice situations.
Okay, that's great. I think also when you're configuring the radios and when you're getting the radios to connect for the first time, only have the one pair running at a time. So because the thing is, yeah, because what we did in the very early days of XinaBox, what you needed to do is that you needed to configure your radios to match each other. But we found that most people only had one kit anyway. So what it is that what happens is when you power it up, your ground station hunts for the flight station and then it connects to it. So yeah, just do them one at a time so that they don't get confused. Yeah,
no interference. Gotcha.
That's good. And then, so would you mind giving, Francis, what is your unit's name? Maybe we can see if we can see it here on the dashboard.
It should just be ground station, to be honest.
Just says ground station. Okay.
Yeah. Maybe I should rename it to make it more specific.
No, I think, yeah, because you know, there may be others who call it ground station, but I'm just going to search. Here we go. Yeah, you see, now we can see where you are. But you know, the thing is what it is. Yeah, the GPS is saying where you are. The ground station, sometimes what we do is sometimes the ground station will also give its address, but that will be for your internet provider. So sometimes that can be, you know, far away.
Yeah.
Is it okay if I share the screen for your dashboard?
Yeah, that's fine.
Okay, you won't zoom in too close, and it's fine because we don't have an image, so it's not like we can see what's happening in your yard. Okay, so is that correct? Is that where you are?
No, I would say not. I'm actually on Florida, kind of by the Space Coast, like Cape Canaveral, kind of.
Okay, and is it connected right now?
Yeah, it's reading on the display. It's giving me like the light readings, and it did say there was like an ALMA error when it started, but I did it with the other one as well, and that still was reading out properly, or AL something, I'm not sure.
CubeSat. Okay, so what I'm going to do is I'm going to just use this generic one here, and I'm going to say over here, I'm going to say ground. So you can see that these little frowny faces over here. This is when it's clearly not working. So here, let's just go here. Okay, let's zoom out. So you can see what it's doing is it's showing Cape Town first, because that's where I'm coming in from.
Right.
And also what it's going to do is it's going to give the time at my location. So because it's 17 minutes past 6 p.m., that's why this looks like this. You know, it's your time right now is, what is it? Is it 6 hours still?
Yeah,
Is it
so it's
2 p.m.?
like 12:17.
Yeah. Yeah, so we should be seeing you kind of around here. Has your flight station got a connection, a GPS connection?
I believe so, but let me, shall I disconnect my ground station from power and then use the display on the flight station?
Not yet. Let me show you and everyone how you do that. So what I'm going to do is that I'm going to go to Discover. Okay, so when you first open the Kibana dashboard, what it does is it actually defaults to this index here called Weather Station. If you can see here on the left-hand side, it says here Weather Station. So, and what that is that is the index that is used by hundreds of students across the world with the STEM starter kit. So that is why we default to that Weather Station. But the one that you're going to be using is called XK07. So that's what we do, is we do that. If we go to that index, we can see that some data has been coming in here. So if we just click on this particular point here, we can see, right? So we can zoom in a little bit. So let's just, that's actually okay. And then we can see here, this is your, so if we open, you see what I did is I opened up the data stream over here. And yes, we can see that you've called it ground station because it says, so what you have here is you can see you've got ground station chips and we've got satellite or flight station chips. Okay. So on your ground station Wi-Fi, your RSSI is -71, which is fairly good. And then your input name that you gave it is certainly it's ground station. So what I could do as well is that I could say up here in my search bar, I could say anything to do with ground. And if I search, then yeah, you see it's picking it up. Now it's only picking up yours. And so if we just scroll down a little bit more here, we can see the dates, satellite connection, you know, that'll either be 1 or 0. That means that you've got a connection between your ground station and your flight station. That's your current on your battery unit, power, battery 0.4, and your power level, 68%, and your voltage. So still pretty healthy. You've got over 2 volts there. And then you've got your radios. So we can see here the ID. You can see here that you see they've got the same ID, 17. And then here your RSSI. Okay, so your volatile organic compounds is very, very, very low. Your carbon dioxide is 400. That's halfway to headache level. So I don't know what you're doing.
It's probably because I'm in like a stagnant room right now.
Yeah. So that's yeah. So you're halfway towards a headache with your CO2. It looks like your light sensor isn't connected. That's interesting.
Which chip is the light sensor again?
SL01, sensor light 01.
Maybe
that's strange.
Maybe it's not connected. Like the contacts aren't.
Okay.
I might need to switch out the little
block
connector.
Yeah, these sometimes the connectors can be a little bit worn, but yeah, let's see why that is. Okay, so you've got the SW03, so you've got your atmospheric pressure and you've got your, I don't know what that is. And then you've got your temperature, that is perfect. Okay, so I'm not seeing your SN01, your sensor navigation 01, which is your GPS. I'm not seeing it here. So I don't think it is connected because it's not sending data.
I believe it's on the same connection line as the SL01, so perhaps it's not receiving power because it's,
Okay. Yeah, so maybe take it apart a bit and put it back together again with brand new connectors and see. Also, the thing is, let me stop sharing quickly. Yeah, you just need to make sure that all of them are facing up so that you can read the codes.
Mhm.
You can see that this is a product that was designed by engineers because the brand is on the back.
Right, yeah.
So if you can see the brand, it's the wrong way around. And you must have your battery unit connected correctly, otherwise it wouldn't be working at all. So yeah, I think just fiddle around a little bit with them, and yeah, they should be working.
How much would you say the orientation of these chips, like the order that they're attached in, affect its performance? Are they highly modular, or like should the antenna always be in a sort of a specific location?
They are. It really shouldn't matter at all.
Okay.
I have my own personal preferences. I like the symmetry of having the antenna in the middle. However, when I 3D print the frame, it doesn't work for me because it now gets in the way, you know. So that is why I actually should have it on in a corner, because then it would be okay. Let me take these out. You see, if I were to reconfigure it, let me just do that quickly so that I have my antenna on the outside. And then when I do that, then I always, for some reason, I always like having the IMU in the center. And I don't know why I bother with that, because I haven't got uniform center of gravity because of the battery unit. Okay, so if it was like this, now I've moved that around a little bit. Now it'll fit into my 3D printed frame. Okay. There's another thing that I do as well, is that with this SD card unit, if I didn't have it on the bottom, if let's say I had it on the top, now I can't get the SD card in and out, so I'd have to take it off every time to put the SD card in and out. So what I do is, while I'm configuring everything, I always have it on the bottom. I have it on the bottom so I can get it in and out. And then when if I want to fly it and I don't want to fly it with a frame, then I'll move it around so that the connector actually almost helps to stop the SD card from getting lost. But so that's just personal preferences.
All right.
Yeah, it really shouldn't matter. But what is important is that you do get the connection. And Francis, if you don't, please let me know, because maybe there's a glitch in the code or something, and then we need to sort it out. We need to troubleshoot it.
Okay, I will absolutely do that. I'll test the connections right now just to see if maybe it's the little blocks that maybe. Yeah, because I must say the connectors don't last well. But I mean, I'm constantly taking it apart, putting it together again. And only last week I had such a challenge. I had another kit that I was using. This is our one here. This is our one for the Sustainable Development Goals. Okay. And I couldn't get it to work. And I had old connectors. So I changed out the connectors and then it all worked perfectly. It was very frustrating. But yeah. Also, the thing is, you should have plenty of connectors. Yeah,
You should have
yeah,
extras.
I have several extras that I'll
Okay.
change them.
That's good. Any other questions? Okay, so let's get together in about another 2 weeks. Let's see how you're progressing and everything else. And if you have any questions, that'll be wonderful. I'm sorry, it's not going to be next week because we are moving this weekend, and then next week I'm going to be unpacking and praying for internet, I think, maybe. Let's see.
Well, best of luck in your move.
Sorry.
Best of
Thank
luck
you.
with your move. I hope it goes smoothly. I know how complicated it can get.
I'm taking my office boxes in my car so, so that they don't get lost somewhere.
Yeah. In 2 weeks from now, that is on the 18th, I have a conference at this time of the day.
Okay.
And but after the 25th, I'm okay.
That's great. Also, Guy, we want you to put your kit together.
Okay.
So we're going to wait for December for you.
No, but this is tomorrow. We're starting the monthly science fair.
Oh, yes, yes, yes. Okay.
Okay,
Good.
and that
Yes.
will keep me very busy.
Yes.
I'm an expert in space ethics, a friend who is coming for 1 week. We have schools, public things, and I won't have a minute for me for the next 10 days.
Okay.
Then I have regional culture where I'm going to hold a booth there. So that will take me till the week of the 22nd November. I have no spare time until the 22nd of November.
That's fine. That's absolutely great. Good.
So anything after that, but don't
Okay.
count on me on anything until
That's
the
fine.
22nd.
Terrific, Guy. It sounds very, very exciting. When are you going to retire, Guy? Never.
The company that employed me retired 15 years ago, and while I was continuing my activities. And in fact, since my company has retired, I have 4 times as much activities as before.
Yes. That's the way it works.
Including, which I
That's
will
the way
show,
it
and I
works.
need you to send me your address for where I can mail this beautiful envelope
Oh,
to you.
yes, please. I will.
Which is
I'm going
called
to do that. Thank you.
build your own model, cardboard model of a CubeSat to go to the moon.
Thank you, Guy. I look forward
So
to that. I'm
send
gonna
me
take
send
my-
me your home address
Yes.
or whatever address you want
That's it.
me
That's
to
my
ship
new
the
home
envelope
address.
to you.
Yes. Great. Guy, that's perfect. Thank you very, very much. That's wonderful.
And thank you.
Great. Thanks. Are there any other questions from anyone? Everyone okay? Good. Thank you so much for joining us. And please, anything, please just pop me an email. And I certainly can't answer everything, but I do have access to those who can. And so, yeah, and I look forward to seeing you next time. It'll be wonderful. Start of a great.
Yeah, I'll try to get together with Willie and we'll work together.
Wonderful. That'll be great. Wonderful. Okay, good. So I'm going to close out for now. Thank you, everyone. And for those of you in Europe, have a fantastic evening. And for Paul and co in the US, have a wonderful afternoon. Good.
Thank you.
Okay.
Thanks so much. Okay,
Thank you,
thanks.
Judy.
Cheers.
Thank you. Thanks,
Thanks.
Judy, for
Thanks.
all
Bye.
your
Thank
thoughts
you.
and good
Bye.
ideas and inspiring.
Of course.
Thank you.
Thank you. Thanks so much. Cheers, everyone.
Bye-bye.
Bye. Bye. Au revoir. I think
So you